Hey everyone, welcome to my channel. Today we're gonna learn about micturition reflex. So like other reflexes, this is also a reflex which is having all the components of reflex. So whenever you get any reflex question, you have to tell about all those components only. Then the things will be very clear to you. So let's start micturition reflex. So how basically bladder is able to store, how he is able to basically micturate or urinate, right? So let's see, basically when urine collects, the pressure rises, we know that, right? So around 150 ml is basically cause of first urge to urinate, and then around 400 ml when the urine is filled in the bladder, there is sense of fullness. So how this occur? To happen this, basically we should have a sensory now which is called afferent, we should have a efferent which is the motor one, right? So one should carry first the stimulus from here. So whenever there is fullness, or whenever there is urine collection in bladder, the stimulus, which is stretch of the muscle, which is detrusor muscle here, when the muscle is stretched, the stimulus is carried via afferent nerve ending, which is the pelvic nerve, S2, S3, S4 segments, and they carry this impulse to the coordinating center, and coordinating center is spinal cord here at S2, S3, S4 level. So from where the efferent parasympathetic pelvic nerve, it again carries the response as effector, and effector here is detrusor muscle, so it's going to contract the detrusor muscle. So ultimately this is the reflex arc which often we talk about in every reflex. There is afferent, there is coordinating center, there is efferent. Apart from these three, the two rest component are the stimulus at receptor level and effector. Okay, so now this reflex is clear to you. Okay, so apart from this, if we talk about the bladder anatomy, there is detrusor muscle. This upper part is body, and where the ureter open up is trigone. Okay, and we have a urethra then, and external urethral sphincter here, and that external urethral sphincter is having innervation of the pudendal nerve. Okay, so it is always stimulating the sphincter to basically prevent urination. Fine. So in normal conditions, the urinary bladder is at relaxed state. Why? Because there are many reasons for that. So we have to, first of all, there is less urine, so no pressure is there. So less firing of the pelvic nerve. That's why less efferent stimulus, efferent response, and less contraction of detrusor muscle. So ultimately detrusor muscle is relaxed. Okay, that's why first thing. Second thing, external sphincter is basically stimulated, so external sphincter is contracted. So this is basically helping in holding the urine and ultimately storage. First thing. Secondly, we know this reflex. So whenever there is collection of urine, this firing occur, and ultimately contraction of the bladder occur, the detrusor muscle occur, and inhibition of pudendal nerve occur. This is the reflex. So if this is involuntary reflex, then how we can control this voluntarily? So there should be involvement of higher centers. So let's say that, so basically what happens is, in Pons there is Pons micturition center here, which is going to stimulate this reflex. Okay, so ultimately this occurs by its own, but if we grow with age, for example for kids, this is not developed, this higher center influence is not developed, so they are not able to hold the urine or voluntarily control it. But as they mature around after 3 months or 4 months, so that pontine center develop and we can control it voluntarily. This is because of the pontine center, and ultimately pontine center is basically stimulating this reflex, and there is area in midbrain which is inhibiting this reflex. So who will inhibit? Who that will help in storage, and who will facilitate or stimulate? That will help in micturition. Ultimately our brain cortex is basically inhibiting this Pons area, so that we can inhibit the micturition whenever conditions are not favorable. Ultimately now I think the point is clear to you how we can control the urination. So cortex is always inhibiting the Pons area, pontine micturition center, and that's how it is basically this stimulation is prevented. Whenever the environment is favorable, this inhibition is removed and the pontine center is going to facilitate it, stimulate it, and ultimately there is stimulation of detrusor muscle and inhibition of pudendal nerve. Okay, and that's how, because of the collection here and relaxation of this sphincter, we are able to void. Okay, and that's how you can write it. So cortex is inhibiting the pontine micturition area. Pontine, which is basically help in voiding, it is going to stimulate the micturition, and on the other hand midbrain is going to inhibit it. That's why it's help in storage. So now at last let's see how you basically make the flow chart of this micturition reflex. So this way you can write micturition reflex at 150 ml. There is first urge. In that condition, 150 cortex is inhibiting the pontine micturition center, and that's why bladder is relaxed. At 400 ml there is fullness of bladder. We can sense it. How? Let's see. So this way we can write all the components of reflex. So stimulus here is stretch in detrusor muscle. Afferent nerve ending here is pelvic nerve. Coordinating center here is spinal cord, S2, S3, S4. Efferent nerve ending here is parasympathetic pelvic nerve, and effector here is the detrusor muscle, which is stimulated here, muscle contraction, detrusor, and response is basically stimulus, the detrusor muscle contraction, and external sphincter is inhibited via inhibiting pudendal nerve. So ultimately response is voiding of urine. So this way you can write the micturition reflex flow chart. The last thing is cystometrogram, which you should know. How basically we came to know that the pressure changes at 150 occur somewhere and at 400 occur somewhere. How we felt fullness at 400 ml. Okay, so that is done by cystometrogram. So cystometrogram is basically when they checked the change in pressure with change in bladder volume. Okay, the graphical representation is cystometrogram and the procedure is cystometry. Okay, so this is the cystometrogram, which is basically here on x-axis there is intravesical volume is shown, means the bladder volume, and here bladder pressure, urinary bladder pressure, and that is called intravesicular pressure. So what is that? Basically the bladder via catheterization is emptied. Okay, with empty bladder they basically injected saline or air every 50 ml and recorded the pressure. So with every 50 ml change in volume they recorded the pressure, and that's the plot they got, right? So every 50 ml this was, so they named this plot as 1A, 1B and 2. These 3 points, this is 1, this is 2, and 2 segments of 1A. The 1A is basically the steeper curve and 1B is the flatter one. Okay, and 2 is the again steeper. So they showed that with small amount of urine volume there is sudden rise in pressure of the urinary bladder. Okay, but after that the pressure doesn't change. Why? Because there is change in tension but radius also change. So this property of bladder is called plasticity. Because of this plasticity property, the tension doesn't change, the overall pressure doesn't change. Okay, as per Laplace law. So then the 2 point is basically around 400 ml urine collection there is steep rise in pressure, and that's where basically micturition reflex started. Fine. So this is basically cystometrogram, which can be asked in your exam. So if it come in your exam, how you have to explain it? First of all, you have to define the cystometrogram, then you have to plot the graph, and you have to explain the component of graph as 1A, 1B and 2. 1A is slight increase with change in volume, 1B is straight line approximately with no pressure change till 300 ml, and 2 is the pressure change, which is the steep curve, sudden around 400 ml of urine. So that's how you can answer this question of cystometrogram. So I hope in this video you are clear about micturition reflex. If you have any query, you can comment below. Thanks for watching. Please subscribe if you like my videos. Thank you so much. Bye bye.